myself Dr. Deepak Kumar Paswan, currently working as assistant professor in Tulsi Ramji Patil College of Indian Technology, Nagpur. Now I am here to deliver the video lecture on the topic of first law of thermodynamics. So, to understand the first law of thermodynamics, which is basically based on the conservation of energy, which has the law that is energy cannot be created nor be destroyed, but transferred from one form to another form. Here. So before that, we should understand the energy. What is the energy? So energy is a form which cannot be created or not be destroyed. So energy is a form which cannot be stored from or destroyed, but the amount of energy will be transferred or converted from one form to the another form. So the total amount of energy in a matter or in a universe remains constant but changing from one form to the another form. So energy is very closely associated with the physical and the chemical changes of any body. If a body has physically changed or chemically changes, so its energy is just the form energy changes, but the amount of energy cannot be changed. Okay, that's why the energy of universe remains constant, but its form changes from one to another form. Now, we should understand the forms of energy. What are the forms of energy? First one is the potential energy. So, potential energy is basically the energy that is the virtue of any body due to its position. Suppose we store water in a height level, in a very high height level, so that energy is stored in that water due to its height, means position. So this energy is called potential energy. Similarly, kinetic energy. If a body is in a motion, so due to the motion of its body, the energy obtained from the motion of the body is the kinetic energy, and having the formula half mv square due to the velocity or motion of the body. So it is a kinetic energy. Then we go to the another form of energy, mechanical energy. Suppose if mechanical energy means it is occurs due to the work done. Okay, due to the work done by any object. If we do any object work done, so the work done obtained in the form of mechanical energy. Suppose in a piston cylinder arrangement, if a gas is kept inside the cylinder, so then if we heat the system of the piston cylinder, so the gas will expand. So it will do some work. So this work is the mechanical work by mechanical energy. Now the thermal energy. Thermal energy obtained due to the heat. So if any body containing heat, so it has a thermal energy in a stored form. Now electric energy. If you see the electric bulb, in an electrical energy, in a mobile electron, it is due to the charge, flow of the charge of electron. So electrical energy will obtain due to the flow of charge of the electron, which is a mobile electrons. Now, the internal energy. So internal energy is the sum of both kinetic energy and potential energy at its constituent atoms. And the heat is the thermal energy transferred from a hotter system to a colder system that are in contact. If a hot body and cold body are in contact, then the heat will transfer from hotter body to the colder body. So this system, so the heat is basically the measure of transfer of, so heat is basically the measure of the coldness or hotness of a body due to the temperature difference by the contact. Another one is the system one. So system work is the quantity of energy that is transferred from one system to the another system. So it is the required amount of energy that will be transferred totally from one system to another system. It is a system work. Now the first law of thermodynamics. First law of thermodynamics say that it is the cyclic work integral of heat is equal to the cyclic integral of work. So it is the increase in the thermal internal energy of a system is equal to the amount of heat added to the system plus the amount of work done on the system. So basically the internal change in internal energy is equal to the heat plus work done. And another is the increase in internal energy of the system is equal to the amount of work heat added to the system minus the amount of work done by the system. So heat added to the system is taken as a positive, heat and heat released by the system is taken as a negative minus, and work done by the system is positive and work done on the system will be negative. So these are the real time example of heat and work. How heat and work are entered or released in the system. So from this example, here you see that in a pressure cooker we are giving the heat, we are adding the heat. So it will be greater than 0, will be positive. If heat is added, it will be positive. Then due to this heat, the temperature increases in this closed vessel in a cooker, so that here the heat will be have some positive work done. So heat is entered and the air work is done due to the heat addition. And in this here, in this system, we have the work done on the system. So the heat is rejected, means heat leaves the system. So it is taken as negative. Now these are some thermodynamic process. First one is the isobaric process. Isobaric process means the thermodynamic process which is done by the at constant pressure. It has a formula omega W is equal to P delta V. So pressure remains constant in this case and the volume will change. So it is the product of pressure into volume. And isovolumetric process means isoporic process. It is also called isoporic process. Means the work means the thermodynamic process which occurs due to the constant volume. Here volume is constant, so in this formula we will put delta V is equal to 0. So work done is 0 in case of isoporic process, and it has the so work done will be 0. So the heat Q is the formula CV by R into V into Pt minus P1. Now the isothermal process. Isothermal process means the thermal process which occurs at constant temperature. For ideal gas, the change in internal energy is 0, and it has a formula PV is equal to NR, which is the real gas equation. Now the adiabatic process. In adiabatic process, heat can neither be leave or add into a system. Means heat is 0. Means here the heat will be 0 in a no transfer of heat outside or inside the system. So it is called adiabatic process. It has a real time example. If we have a thermos flask, so heat will neither go outside the thermos and it will not heat at inside of it. So the heat is transfer is 0 in case of adiabatic process. Now that's all. We will discuss the second law of thermodynamics in our next session. So thank you for listening. Thank you.